In this video, we will solve the polynomial inequality shown here. We will write our answer in interval notation. So, the first thing you do to solve a polynomial inequality is you solve the related equation where you make an equal sign instead of a less than or equal to sign. This will give us the boundary points that we need. So I'm noticing that I have x's in every term. That means there is a common factor of x. So the first step of factoring is always to factor out any common factors. So I will take that x and pull it out front. So that will leave x squared minus 2x minus 15 equals 0. Now I will try to factor this further. So I will keep my x out here and I will try to factor this. X squared can only be factored as x times x. 15 is probably going to be 3 times 5. Inner plus outer equals middle. Inner, I've got 3x. Outer, I've got 5x. Okay, I'm trying to get a middle of negative 2x. So I can get negative 2 if I have a positive and a negative. Positive 3 and a negative 5 makes negative 2. So that means positive and negative here. Also, that makes negative 15 because positive 3 times negative 5 is negative 15. Now I will set each of these factors equal to 0, starting with x equals 0. If I do x plus 3 equals 0, I get x equals negative 3. And if I set x minus 5 equal to 0 and add 5 to both sides, I get x equals 5. So these are my border points, my critical values, which I will graph on a number line. So here comes the number line. You know what? Let me go like this. So here's my number line, and my critical values are negative 3. You know, I'm going to put them in order, of course. So my critical values are negative 3 and 0 and 5. So I'm going to represent, so these are the places where the function equals 0, because that's what we solved. We found the x values where the function equals 0. So do we want to include the solutions that give you 0 in our solution set? Well, we want to know where the function is less than or equal to 0. So we want to include the zeros. So we will include them by making them closed circles. Okay, closed circles means these points are included. If this had just been less than without the or equal to, then I would have done open circles instead. Okay, so now I have 1, 2, 3, 4 zones. My number line is divided up into 4 zones. I need to do a test value in each zone to find out if solutions are there. If I find one solution, then all of the numbers in that zone will be solutions to this inequality. So you can pick any number you want that's in this zone. So I'm at negative 3, so I need something less than negative 3. So I'm just going to do negative 4, but you could have done negative 5, negative 6, whatever you want. I need a number in this zone between negative 3 and 0. I think I'll do find the value of the function at negative 2. I need something in this zone. I think I'll find the value of the function at positive 2. Okay, I need something in this zone. I'll do the value of the function at 6. Okay, let's do it. Now I am going to use my TI-30XS multiview to help me evaluate the function at these 4 places. Okay, so first I need to type the function into my calculator. So using the table feature. So here we go, x to the third power minus 2x squared minus 15x. Okay, that's it. So the function's in the calculator. Now, it doesn't matter where I start because I am going to use the ask feature instead of the auto feature. Okay, since I know exactly, I don't need to hunt for the x values, I know what the x values are that I want to do. It's more convenient if I do it this way. Now, just to be clear, I'm going to delete this out. Okay. So these are the values that I am dealing with. So I want to know what's happening at -4 and -2. So here I go, -4 and -2. Type those in. So I got -36 and 14. Okay, so I got -36 and I got 14. Now in each case I want to know if the function is less than or equal to 0. So is 36 less than or equal to 0? Question mark. Is 14 less than or equal to 0? Question mark. Well, in this case, yes. Negative numbers are always less than 0, so that's a yes. Is 14 less than or equal to 0? No. Alright, 14 is obviously bigger than 0. What about 2 and 6? Let's go ahead and do those. So I'm just going to delete, and I will now put in 2 and 6. So I get -30 and 54. Okay, so I got, whoops, I didn't leave space for my negative. So I got -30 and I got 54. And again, I'm asking, is -30 less than or equal to 0? Is 50, why did I just put a question mark? Messing up. Is it less than or equal to 0? Question mark. Is 54 less than or equal to 0? Question mark. Yes, -30 is less than or equal to 0 because it's negative. 54 is not less than or equal to 0. So I have a yes, no, yes, no. The yeses mean that this is a solution, so therefore all of the points in this zone are solutions. I will indicate that by putting an arrow here. And I see a yes here as well, so that means all of these are solutions. I will leave the no zones just empty, indicating that there are no solutions in those zones. Now, as my final act, I need to translate these solutions that I have graphed into interval notation. So this arrow over here on the left is from -infinity, okay, over to -3. And because it's a closed circle, that's a -3, I'm going to put a bracket. From 0 to 5, we have solutions. So 0 to 5, bracket, bracket, bracket. It means the same as a closed circle. It means included. Whenever you have two parts to your interval, you're going to put a union between them to join them as one answer. Now, before we look at these answers, this particular piece of software, instead of using square brackets, they're using these braces to mean the same thing. So just understand that everywhere you see a brace, that's supposed to be a bracket. Okay, so now let's look. -infinity to -3 is looking like D. And then union 0 to 5, bracket and bracket. So the answer is D.